All right, we are going to do one final example, and it's a little bit algebraically involved, so bear with me, okay? So this example is example 8.7, okay? And the problem states, suppose the following experiment is performed. So we have a object with some mass, m1, is equal to 0.25 kilograms. It slid on a frictionless surface into a dark room where it strikes an initially stationary object with a mass of 0.4. So M2, 0.4 kilograms. Okay. And then after the collision, the first mass emerges from the room at this angle. Theta 1 equals 45 degrees, okay, with its incoming direction. The speed of the initial object, or the first object, M1, is originally 2 meters per second, and that velocity changes after the collision to 1.5 meters per second. We want to calculate the magnitude and direction of the final velocity of the second object. So V2 prime and theta 2 of that object, okay? So again, V2 was 0, okay? So let's go ahead and picture this for a second. So we have our first object, M1, collides with our second object, M2. And then M1 goes off, I should make that a little more accurate, goes off at about a 45-degree angle. And then we want to know what this angle is, theta 2, and that other velocity of this second object. Okay, so this little object, and then what happens to that second object. Okay, so for this, we will need to use a few equations that we learned in our lecture. Okay, so let me pull up our lecture real quick. It's not this one. It's going to be our conservation of momentum equations in the x and the y axis. Okay, so if you notice, this is, let me go ahead and put it full screen. This is exactly what we have. So we have some mass with some initial velocity that hits another mass that has no initial velocity, okay? And then they go off at some respective angles, okay? So this is exactly what we have, and this is what we are going to follow. Whoops, okay. All right, that made it a little easier. Okay, so this is what we'll do. We know these two equations from conservation of P, okay? So we're going to use these two in order to calculate our V2 prime, all right? So let me go ahead and start with along the x-axis. So we have M1 V1 equals M1 V1 prime cosine theta 1 plus M2 V2 prime cosine theta 2, okay? And if we want to solve for our V2 and our theta 2, let's go ahead and rearrange this in order to do so. Okay, so let's go ahead and say M2 V2 prime cosine theta 2 equals M1 V1 minus M1 V1 prime cosine theta 1. Okay, let's look at along the y-axis now. So we have 0 equals M1 V1 prime sine theta 2. My dog is mad at me again. Plus M2 V2 prime sine theta 2. Okay. So now we can do something similar and solve for this term here. M2 V2 prime sine theta 2 equals M1 V1 prime sine theta 1. Okay, that should be a theta 1. Whoops. Go lay down. Oh boy. Okay. So what we can do with these two equations is actually put them together in a way that might be a little bit confusing. Okay. So what we can do here in order to combine them is actually divide one by the other. Okay. So if this is equation 1 and this is equation 2, what I'm going to do is go ahead and divide divide equation 2 by equation 1. Okay, so I'm going to divide these two. And you'll see why here in a second. So I have M2 V2 prime sine theta 2 divided by M2 V2 prime cosine theta 2 equals M1 V1 prime sine theta 1 over M1 V1 minus M1 V1 prime cosine theta 1. Okay, now as you can see here, my masses will cancel, my velocities will cancel, and now I'm just left with one variable, okay, and that is theta 2. So remember that sine over cosine is actually tangent. Okay, so we have tangent of theta 2 equals this here. And we know all of these values, so now I can take the inverse tangent of both sides and solve for theta 2. Okay, so let's go ahead and say that tangent of theta 2 equals my mass with the first object is 0.25 kilograms times my initial velocity of the first, which is 2, or I'm sorry, it's actually the final velocity, or so the velocity after the collision, so that's 1.5 meters per second, times sine of the angle, which was 45 degrees, okay, divided by 0.25 kilograms times my initial velocity, just 2 meters per second, minus my mass, 0.25 kilograms, times that velocity after the collision, times my cosine of 45 degrees. Okay, so we can get a calculator out and solve for that. and we end up with 1.13. And again, this is equal to tangent of theta 2. So we can take the inverse tangent. So theta 2 equals tan inverse of 1.13. And that gives me that theta 2 is going to be about 48.5 degrees. Okay, so that's the angle at which my second mass is going to be traveling, okay? But now we also want to know that velocity. So our velocity is described by both of these equations. Let me just use the shorter equation here. Okay, so I'm going to look at equation 2. And it will be V2 prime equals M1 V1 prime sine theta 1, right, divided by M2 sine theta 2. Okay, so we can plug all of those numbers in. 0.25 kilograms, 1.5 meters per second, sine 45 degrees, divided by M2, which is going to be, what was M2? Second mass, 0.4 kilograms, times sine of that 48.5 degrees. Okay. So now I can plug that into our calculator, 0.25 times 1.5 times sine of 45, divide that by 0.4 times sine of 48.5. And we get that our velocity is now 0.885 meters per second. Okay. So this is our velocity after the collision and what direction it's going in. Okay, now remember that this does make, let's see, does this make sense? I guess should be the question, right? We want to make sure that all of our answers are making sense. So we had an object traveling at 2 meters per second, and then it lost, once it hit the other object, it lost some speed and went off on some angle. Now our other mass was initially at 0 meters per second, so it wasn't moving. And then as it after it got hit or collided, it gained some velocity. So this does make sense. Okay. All right, those are all the examples I wanted to show you. Stand by for more information on homework and such. I hopefully should be posting that pretty soon. All right, thank you guys. See you next time.